Okay, so last time we introduced the phase changes. We know basically for all matters, they have three states: gas, liquid, and solid. And these states can transfer each other. For example, if the gas changes to liquid, we call it condensation, and if liquid changes to gas, it's evaporation. And also the liquid changes to solid is called freezing, and the solid changes to liquid is called melting. And we also introduced what the boiling point, and the molar heat of vaporization. So molar heat of vaporization is the energy required to vaporize 1 mole of liquid at its boiling point. And we also know this equation. So from this equation, we can see the relationships between the pressure and the temperature. So from here, we can see when the pressure of gas increase, so its pressure also increase. And we can use this equation to do some calculations. For example, we can calculate the pressure or temperature from in different situations. Also, we introduced the critical temperature. So the critical temperature is the temperature above which the gas can't be made to liquefy, no matter how great the applied pressure. For example, the critical temperature of water is about 374.4 degrees. So this means if the temperature is more than this one, the water will be always the gas will be always the gas state. It can't be become the water, the liquid. And we also introduced the solid and liquid equilibrium. So here is the molar heat of fusion. And of course, when we melt the solid substance to liquid, we need to provide the energy. And this energy is called molar heat of fusion. Okay, so this is a heating curve. So from here we can see the y-axis is temperature, okay, and this is time, heating time. At first, when the temperature is low, the substance is solid, right? And then when we heat the substance, and its temperature will increase, right? As time goes on, the temperature will increase like a line. And then at A situation, so at A, this means the solid and the liquid in equilibrium. A, this temperature is the melting point. So when the temperature is at the melting point, so this means the solid changes to liquid, and the temperature will not change. Will keep at the melting point for a while. So my question is why? Why at this during this time, the temperature will not change. When it arrives the melting point, and when we heat the substance, but during this time, its temperature will not change. Why? Why? What? So basically, for example, we heat the substance, and at the solid state window, if we give the energy, the temperature will increase, right?
Yes.
And but at the melting point, now it changed to liquid. But during this melting time, the temperature will not change, will not increase. Why? Where's the heat? Basically, the substance, if the substance gets heat, its temperature will increase, right? But why during the melting point, melting process, the temperature doesn't change? Yeah.
I'm trying. So maybe the heat is used to change the substance from solid to liquid.
Yes, because the energy is absorbed by the substance, changed from solid to liquid. So during the melting time, the temperature will not increase. Will not increase. All the energy are used for melting the solid. Okay. When from A to B, at the B, this means all the solid changed to liquid. Okay, all the solid melt and become liquid, and then the temperature will increase again, right? Okay. Okay, when it arrives C, it means the temperature is at the boiling point. Boiling point, what's boiling point? Boiling point means the substance changed from liquid to gas, right? So this means boiling point. So from when it starts to change from liquid to gas, and during this time, the temperature will also keep the same. Okay.
Last year.
Yeah.
So from A to B, the solid
Yeah.
changes to liquid completely.
Yes. Yeah. At first all A all solid. Okay. And B all the substances are liquid. Okay. During A and B, so some are solid, some are liquid. Okay. And C to D is the substance change, all substance changed to vapor gas. Okay, so why? But during C, from C to D, the temperature doesn't change. Why?
Same reason.
Yes, the same reason. Because all the energy are used to change the liquid to gas, to vapor. Okay. So when all the substance changed to vapor, and then the temperature increase again. Okay. So this is about the heating curve. Heating curve. From here we can see during at the different in different time the temperature may show different situation. Sometimes when the substance is pure solid or pure liquid or pure gas, so its temperature will increase. But at the equilibrium situation, so the temperature will not change because the energy should be used to to change the solid to liquid or change the liquid to vapor. Okay, so any question for this? Okay. So this curve we can get this curve from experiments. Okay. Okay, the third part is about a solid gas equilibrium. So this means the substance changed from solid to gas directly. Okay, it will not change to liquid just from solid to gas. For example, this is iron solid. Okay, when we heat, it will directly change from solid to gas. So this procession is called sublimation. And of course, when the temperature decreases, the gas will directly change to solid. So from gas to solid is called deposition. And from the solid to gas, it needs energy, right? This energy is called molar heat of sublimation. Okay. So molar heat of sublimation is the energy required to supply one mole of solid. So we can use this. So this SUB and SUB that H SUB equal to fusion and vapor. If it has if it can change from solid to liquid and liquid to gas, so this energy and this energy should be equal to this energy. Okay, this is Hess's law. Okay, this is about the solid gas equilibrium. So this is all we learned last time. So today we will start a new chapter.
So, Moshi,
Yeah.
so can you open the PPT using Microsoft PowerPoint?
I don't know why. You mean you should select another? Where? So what's the difference between?
If
So
we do the
open? Yeah. There we go.
the thing is, when we do something on the board,
Yeah.
when we use this one,
Okay.
it doesn't, like when we use this one to draw,
Okay.
it doesn't
Oh, you're gonna show here.
in the
Okay,
PPT.
good.
But if we use this one,
Okay. But sometimes maybe we also want to record what we draw here.
Yeah, that's what it's saying.
Yeah, I know what you mean. You mean we don't have to use it this way. This here will not record.
yeah, but if we use this one, it can just record. It shows you.
They also show here. Okay, I see. So there are more choices.
Yeah.
So you can record it or not. Okay, I see. Okay.
What else do you?
We're on the same page
Okay.
for writing. We're on the part for writing. Just going there, then
Okay. Okay. Thank you. Okay. Good. Okay. So now we introduce the chapter 10. It's about the introduction to reactions in aqueous solution. So basically, there are three. In last chapter, we learned all substance have three states. And solid, liquid, and gas. So most of the reactions happen in aqueous solution. So in this chapter, we will introduce the reactions in aqueous solution. So we will introduce some basic concepts about solution and also the reactions in some very common reactions in aqueous solution, like precipitation reactions, acid-base, like neutralization reactions, and the third one is about the oxidation reduction reactions. And then we will use the reactions to do some calculations. So it's about the solution stoichiometry. Okay, so we know solution. So a solution is a homogeneous mixture of two or more substances. If only one substance, so it's called element, right? But in a solution, it may have two or more substances. So this is called a solution. Okay. So for these two or more substances, some are called like solute, and one is called solvent. So solute is or are the substances present in the smaller amounts. So this is solute. And the solvent is the substance present in the larger amount. So in one solution, so my question is, how many solvent, how many solvent in one solution? How many solvent? One, yes, only one. Okay. In a solution, only one substance is solvent. Okay. And this is the present in the largest amount. So others are called solutes. Yeah, the solute may be one or two, right? So for example, we will drink, soft drink. So the solvent is water, but solute can be one or more substances, like silk, and in the water there are also some carbon dioxide. So this is the basic solution. So this is the commonest solution. So the solution is liquid. It's in liquid, right? Air. The solution also may be gas. For example, air. So the air, we know there are many gases in the air, right? But the nitrogen is the largest amount one. So the nitrogen, we can say the nitrogen gas in the air, the nitrogen gas is a solvent. And other gas, like oxygen, they are solute. Okay. The solution may also be solid. For example, there are some lines. We can mix two or more metals together. Okay, so this is called anions, metal anions. So in the metal anions, one metal with the largest amount is solvent. Okay, and the other metals are called solute. So here, so solution. So basically, basically the solution is in liquid state, but they also can be gas or solid state. Okay. So here question. So in this solution, KMnO4. So what is the solvent?
Okay.
In this aqueous solutions of KMnO4. So what is the solvent? No. Aqueous. What mean aqueous?
Liquid.
Yeah, in water.
Yes.
Okay. So in this solution, what is the solvent?
Ah,
Water. Yes. The water is the solvent. And the KMnO4. This is one compound, right?
yeah.
So this is solute. And in different concentrations, let me show.
Last
Yeah.
So just saying is any aqueous solution, even if the houses like that came and water. Since we know water is H2O and it would make sense maybe if hydrogen was also there to kind of show that water is present. So since there's no hydrogen there,
No.
it's still just
The alcohol, you know, the H2O, right? It's a compound. You can say hydrogen. Alcohol is water. Water is a compound. Okay, so there are only two substances. One is water, another is this. Okay, you can also like sodium chloride. Okay, sodium chloride, of course, it has three substances because you also like in here, you can also like three. One is water, because in this solution, the K will and the MO4 they will separate, right? There are three substances, and the sodium chloride solution, you can also say there are three substances. One is water, so water is a solvent, okay, and the sodium and the sodium chloride, in water they will like sodium cation and chloride, right? So sodium cation and chloride and iron are solute like this. Okay. So echoes. So definitely in this system, the water has the largest amount, right? You can see this has more amount than water, right? If you calculate their moles, of course, the more number of water is much higher than the other moles of substance. Okay, so of course, in this system, in this solution, the water is a solvent. Okay, and of course, if you can make other kinds of solvent, the water, there are very few water. Okay, for example, the air. Okay, the air is a gas solution, and in the air there are some water vapor, right? So the water is less than the nitrogen. Okay, the water is less than the nitrogen because in the air most substances are nitrogen, or the nitrogen has the largest amount among these substances. Okay. So for solution, there are two kinds. There are like three kinds of solution. One is called no electrolyte, and weak electrolyte, and strong electrolyte. So electrolyte is a substance that, when dissolved in water, result in a solution that can conduct electricity. So this substance is called electrolyte. It has electrolyte.
you give us an example?
Sodium chloride. Okay, sodium chloride. For example, sodium chloride is electrolyte because in the water it can be separated to sodium and chloride, so it is electrolyte. So no electrolyte is a substance that when dissolved result in a solution that doesn't conduct electricity. Electricity. So here we can say if it's no electricity, so this means the electron can be transported between these two sides. So the bubble it doesn't bright.
Gotcha.
Yeah.
So water is a water conducts electricity, right?
What
H2O.
H2O is a weak electrolyte.
But it does conduct. Okay, so in short,
It's very weak. I will introduce more about the electrolyte of substances.
now my question is so the way we set up a circuit, right? An electric circuit. Is it okay or is it possible for us to use liquid as a conductor?
Yeah, in liquid.
As in an electrolyte as a conductor. Since you know wires, is it okay like I even get a cup where I put the wire this side and the wire this side, and in that container there is an electrolyte.
Yeah, in this case, this is called a strong electrolyte.
And I draw.
Yeah.
Make sure.
So okay, maybe here is the switch. Then there's the valve. Then what? So I don't know which side I got there. So here is liquid, which is the electrolyte I'm talking about. Then so I'm saying since we're using this as part of the wire, as part of the circuit.
Yeah,
Yeah.
of course.
So
Yeah,
when you close the switch here,
yeah.
this will like
Yes. For some if the substance is electrolyte, and when you close here, so the Bible will light. Yeah, of course. Oh, how to retain?
oh because
Okay,
I had a feeling that one.
so like this. So another side is about the power, right? When you go and then, for example, like this line from here, the electrons can move from here and through the solution to here, and then like it can go through the pipe, and then the bubble will light. Okay, so in this solution, the substance is a strong electrolyte. And if it's weak, you can see the bubble is weak, right? The light is weak. If it's no electrolyte, so no light here.
Okay. So what property of the electrolyte makes it strong? As in,
No substance, right?
yeah, what property of it makes it able to be strong?
This is here. This is why is strong. For example, strong electrolyte. It means the substance can fully dissolution. Okay. For example, if in the solution, in the water solution, sodium chloride we dissolve sodium chloride into the water. So this sodium chloride solution, it has strong electrolyte. Because the sodium chloride will become sodium cation and chloride and iron. And we know these, they can transfer electrons. And the weak electrolyte means not complicatedly dissociated. Like this, we know this is a weak acid, right? We introduced the acid. So this is weak acid, and just partly is dissociated. So there are very few ions in the solution. So this solution is weak, has weak electron, has weak electrolyte. Yeah, question.
Can you help us say that we can also say it's a strong electrolyte if the reactant is in the group 1 and 2 issues? I mean, for instance, sodium, potassium, calcium, all those strong metals and everything, all those highly reactive metals, if they are part of the reactants, can we say it's a strong electrolyte? Like if it's, let's see, sodium chloride, right?
Yeah.
Yeah, the sodium is from the group 1, from those.
So basically, for example, if it's electrolyte is must there are some cations and ions in the solution. If there are some cations and ions in the solution, so they can transfer electrons. So they have strong electrolyte. If there are very few ions in the system, so they can't. They have weak ability to transfer electrons. So water is also weak. We know water is in the solution. For the water, the H and OH concentrations are about 1 times 10 minus 7, right? So 10 minus 7, 10 to the power of minus 7 is also very weak. Okay, it's very small. It's like this. For example, this Ka number is bigger, is larger than water. So this is called a weak electrolyte. And of course, water is also a weak electrolyte. But if we dissolve the sodium chloride into the water, so the water solution will become strong, will become to have a strong electrolyte.
Then, right, like, if water is an electrolyte, right, and then, okay, why does it cause an explosion if you, for instance, like, spew water in a socket where there are things like there's electricity and everything? Because if it's an electrolyte, it means it's simply a conductor, right?
Yeah, yes, yeah, conductor, yes.
Why does it do the short circuit thing where it starts sparking?
Oh, what's the question?
The question is, if water is an electrolyte,
Yes, it's weak. It's a weak electrolyte.
so it being weak, does it mean, okay, if you put a weak electrolyte in a strong, I don't know, current flow of electricity, I don't know what to say, does it mean it won't act as a conductor, but it will act as a...
Yes, the conductor is come from the strong, because you put some strong electrolyte like sodium chloride into the water, and of course the conductor is most of the conductor is come from the strong electrolyte substance, and of course the water is weak, and the water also can. So this is why, for example, if the substance. Okay, like this. If on the ground there are some water and have electron, so you can feel the electron. If no water, of course, there are some electrons over there, you can feel the electron, right? But if there are some water on the ground, you may die. Because the water can also is a weak conductor. Is also conductor the electron.
So what gives more a weak electrolyte or a strong electrolyte?
Weak, but people is more is very weak. If just only small conductivity, you will also die. Yeah, the weak strong is just compare the conductivity. Okay. So here we can see some substance has strong electrolyte because they can completely dissociate to cations or anions. Okay. If it's not completely dissociated, so it's called weak electrolyte. Because this is neutral, okay? If it's neutral, it can't conduct electron. So this is also like a reversible reaction. So what this means, in the system, there are some neutral molecules, there are some anions, and some cations. And when this looks like when this dissociation is around the balance, the concentrations, their concentration will not change. Okay, so when we can see for this acid is a weak electrolyte because its ionization in water is incomplete. Okay, because in most solution, most of the substance is neutral. It's neutral, so it has a weak electrolyte. So basically, for example, for iron and cation in water solution, there will be say like this. Each one will be surrounded by water molecules. So this is called hydration. So hydration is the process in which an iron is surrounded by water molecules arranged in a specific manner. Using this way, for example, this is cation and this is water. So the red ones are oxygen. Okay, the green ones are hydrogen. So from here, the oxygen will close the cations. So we know this process, right? So we know they are like intermolecular forces, like dipole forces, ion dipole forces, dispersion forces, and hydrogen bond. So, for example, if it's sodium, so all the intermolecular forces between the cations and the water. Remember? This is sodium, and this is water. Between the sodium and the water, what intermolecular forces? Okay, have a short break.